Great. So, very good afternoon, one and all here. So, I think since this morning we've been hearing a lot about data science use cases, ML models, AI implementation, and I think I'll be talking a little bit something more fundamental, which is about the data itself. I think your models can be as accurate as the underlying data only. So I think having an effective data management and how we treat data is critical for this journey. And I'm going to share our experience or our journey in this direction, how we are moving more closely towards data products. Yeah? My name is Vinoth Kannan, and I'm a product manager at Daimler Trucks at the data platform and foundation team. So before I go into the presentation, I just want to give you a context about where we're coming from. Probably everything you own today, or you will own, at some point in time had been in a truck, And I'm proud to say that we are one of the biggest commercial vehicle manufacturer in the world. And we share this mission that we support all those who keep the world moving. So, and we are, we are a 100 years old company, but still yet spinned off from the passenger car division just last year. So we are less than a year old as an independent organization. We have so far 7 brands. That's in almost every continent you can say in the world, and we have more than 100,000 employees. And as you can say, one of the main vision for the organization is that we want to lead the sustainable transportation of the future. So not only about cars, but also commercial vehicles, the trucks which you're seeing today, needs to be also become sustainable, should be more electric or more run on hydrogen-based fuel cells, and we are trying to lead that mission. And as you can see that for this to happen, we need to be more innovative in terms of how we are treating data. For example, all our trucks are streaming data, which we are collecting. We have to collect how our batteries are performing. We need to understand how we are able to understand the quality and warranty issues that are happening for our trucks to make sure that we are more responsive and more customer-oriented. So all this means that we have to collect data from every second from our vehicles, from the first nut or bolt that's been put on the truck till it's finally in the end of the life cycle. So with that, the focus is we want to build more digital services. We want to operationalize our make efficient operations and all these things we have to do. And for that, data is critical. And these are some of the key use cases which we see in the organization where we have a tremendous potential, right? Which is, for example, customer behavior analytics. So to understand how a user or driver or is using the truck can determine what kind of R&D or design goes in the next version of the truck. So it's very critical that we are collecting this data and analyzing it. Global supply chain management. So as you can see, a truck has many parts, and due to the supply chain constraint we're having, we need to understand where each and every part is coming from, so we can optimize our supply chain and manufacturing, so that the trucks are not laying around in the plant, but we are immediately able to ship it to the people who are buying it. Predictive analytics for product quality, right? So to understand when something can fail, so that we're able to react faster, we can get the spare parts in time before they even happen, so that the whole experience for the end user is not less pleasant, less unpleasant, I'm sorry. And finally, in the finance aspect as well, to giving the right insurance and leasing plan. We also have a financial services organization that's supporting this. So we see data analytics having a huge potential for our organization. And the way we are doing for the last couple of years is probably, the so-called data lakes, right? So, we used to collect all the structured, unstructured, semi-structured data, everything put on a common data lake, and we ask questions which we don't know. This was the concept behind data lake, which was introduced mid of last decade, 2014, 2015. The whole concept was there, and I think many of us bought into this, and we tried to do this because simply the data volume was exploding to be stored on any traditional relational database, so we have to go to a big data platform for doing our analytics. And of course, we have all these different use cases, like we want to do batch querying, interactive, real-time, so we have all these use cases, the whole business chain, supply chain from end to end, from production, quality, sales, after sales, finance, everyone wants to do analytics, and there is a huge demand, and they want to work across domains. So they want data from the production needs data from sales, the sales need data from after sales, so really people need to have a cross-domain need, and it was logical at the time to put everything into a common data platform and then ask the right questions. But what we found was it was not that easy. You're putting a schema-less data into a central place. And there's a central team. Normally, the data lakes are owned by a central organization in your department, which is onboarding your data. And if your organization is huge, let's say you want to onboard 300 to 500 sources in a year, a central team cannot handle it. It becomes a huge bottleneck before you can start working on the data. As a data scientist, it can be an extremely frustrating experience if you want to start with the data, working with the data. And even if you have access to the data, the quality is so bad, you spend 90% of the time just cleaning the data before you can do your AML. So as you can see, it's a very fundamental foundation problem you're trying to address. And I think this is where we hit a kind of a wall, and we realized that doing things in a centralized way has its advantage, has its limits in terms of scaling our data platform. And also, we clearly need to bring more accountability. An example is, in talking about accountability, is a data on a transaction system has a clear owner. If I'm a salesperson, I take care of all my CRM data in my CRM system, but as soon as I give the data for analytics, I'm not responsible for it. Let the data lake guys, platform guys take care of it. My job is just to focus on the system. I think this is a fundamental mindset we have, and when you want to take high quality, critical decisions based on the data that's in the platform, but there is no team or no one taking accountability for this data, then it's a problem. So this is where I think we realize that in this manner, the fancy use cases which were successful in our laptops, like the proof of concepts, as soon as you want to scale it across the organization and put it to production, we are hitting a wall. And which is as simple, right? So we want to get from data, which is from the siloed data, to information, where you're connecting one or two features, to knowledge, where you're truly able to bring all the data together to bring value. And the real value for the organization is somewhere here, but because of the way we are using and organizing the data, we cannot go beyond the second stage where we're just putting together just 2 or 3 sources together. And this, I like to call it the data product value chain. And the more you are towards the left-hand side, towards knowledge, the better value you can get. And less mature you are, it's a challenging aspect. So in this case, it's very clear that we need a change in our mindset. We need to move towards a so-called a data product approach. What is a data product? Is something we need to clearly have a definition, because we can talk about data products, but what exactly it is. People know any pen or a notebook as a product, but what is a data product? So it was very important for us to get a clear definition to the organization for them to understand in a language which we can communicate. So we told a data product is nothing but it's a set of data and a documented metadata. It needs to have both. A data product should contain a data and a metadata, and it is relevant for someone to consume. So without a consumer, there is no product, like in any physical product. So we want to make sure a data product should have a consumer, and it should have a documented set of data and metadata. The second set is that we want to have a clearly attached set of access policies. So a fine-grained access control, there should be a policy behind every data product. Who can consume it, who cannot consume it, how much they can consume it. Because in a typical data lake, maybe we have historical data, and if someone wants access to it, we just give the whole data to them. But if you're talking about customer data, which has PII information, maybe from a compliance perspective, it doesn't make sense. Or maybe the use case just needs data for the last 6 months or 1 year, but you're giving them the complete history. So I think it's not needed, and it's important that a data product has a clear set of policy behind them in terms of who can consume it and who cannot. A third is, as most critical, is it is owned and managed and provisioned by a data product owner, and there's a team that is managing it. So far, this has been a central team, and we think that this approach should change. We need to make sure that this central ownership is not scaling, and it doesn't make sense. A single team cannot know about 500 sources or 600 sources. It needs to be the individual domains and should take ownership for those data sets. And finally, it should have a life cycle. A data cannot live there forever. It should have a life cycle, and there should be a clear service SLAs in terms of quality and other aspects. So I think with this definition, we went on and looked at our current data structure, data platform, and we thought that the current data lake, our data platform, doesn't work for this purpose, and we need to move towards a different approach. And for us, the data mesh paradigm was more fitting to our need. As you can see, we want to move from a centralized ownership, which was the case in the data lake, to a decentralized ownership, so where every data product is owned by an individual data product owner. We want to move from a monolithic to a distributed structure. And in a data lake, you see data as a byproduct. The focus was on infrastructure. We want to connect this source to there, and we want to take care of the pipeline. And finally, no one is really talking about data. For the team that is ingesting the data, it's just files in some format. It's not meaningful for them. They don't know the significance of them. So here, clearly moving away from the data lake to a mesh approach, we want to take the focus away from the infrastructure and make the focus on the product itself, which is the data. What are we really trying to offer? What are we trying to solve? Who is owning the data? So changing the focus from infrastructure to the product was the next biggest change towards this approach. And finally, moving away from pipelines to domains, so having this as the first-class concern. So this platform, which we designed, had these 4 capability blocks, as we call it. The first block is, as I mentioned, the data foundation block, which makes sure that we're treating all data in this platform as products. The second block is analytics platform. So here, bringing the tools, right tools for the job, so that the data scientists can have the tools they need to work with the data products they need. Thirdly, we want to make sure we are generating the right value and insights from the data. So making sure that we are able to offer the right data and tools so that the right insights are generated. And oftentimes, even though the insights are generated, it's not in the hands of the decision makers. The last mile delivery is missing, right? So we brought in a 4th delivery block called service delivery, where making sure the final consumers are having hands on this data. So it could be through something like a data marketplace, or through APIs, or through even a simple web app can do. But finally, making sure that we're able to consume the data which is being generated from a data scientist environment. And also make sure that the platform itself has all these different principles in terms of fully automated and also compliant and secure, and also a global platform. Since we are a global organization, we don't want to build the same environment in different environment, different places. We want to make sure that it's scalable and also replicable in different across the world. So in terms of Azure, so when you say replicable, how it works, right? In terms of cloud, right? We're using Azure as the main stack here, but it can be any cloud. Let's say this Lego brick is like a standard Azure stack. Our data lake looks like something like this Lego castle, right? So we have a central team that is managing this data lake, and they are making sure they're controlling all the exits and entrance. They have to ask permission to enter the castle. You need to, before using a tool, you need to ask them permissions, and there are a lot of restrictions. And I think to go towards a data product, we have to first fundamentally change the basic infrastructure. That's what we did now with Intructs, which is moving away from such centralized approach to a decentralized small houses like this. So each data product owner is owning their own mini houses, which is kind of a miniaturized data lake, you can call it. It has all the functionality of this big data lake because it's all PaaS services, probably. So they can onboard the data, they can manipulate the data, and they own the data. When they own it, they take full accountability for the data. If they don't have the capabilities to work with the data, then of course there'll be some enablement services where a central team can support them in terms of doing some technical aspects. But clearly, our approach is giving the ownership and accountability to the business side, people who own the actual data on the transaction system in the analytics environment as well. And end-to-end, this looks something like this, right? So the data from different sources are connected to different data products. So it can be any of the consumable data products using this tool stack, but it can be much more than this as a data products, as a data foundation block. And then you offer the right analytics environment. It could be much more than this, but maybe for example reason, we're just sticking with that for the analytics block. And then you're doing your different use cases. It can be deep learning, normal analysis, simple reporting, real time, it can be anything. And finally, you're consuming it through a data marketplace, a Tableau, a Power BI, a web app, etc. So I think this is just an example how we can move away from such monolithic platforms into smaller environment, and yet make sure that platform is scalable. We make sure that the data quality there's accountability behind the data, and making sure that we're improving the overall process about the platform, behind the platform. And what we're trying to really establish here is a data product ecosystem. As a first step of this, there are the three key milestones behind such implementation. So first, as I said, right, building such a platform that supports data products, that's first critical, moving away from centralized platforms to more decentralization, so you can still do the same activity but in a decentralized way. And then really establishing the principles of data mesh and culture behind data sharing. So once the platform is there, the next step is that convincing people why they should share their data. That's another second reason. And here, a clear data culture for sharing data and also why they should do is important. So we really went and spoke with some of the guys who are more interested, the guys like Lighthouse domains who are interested to do it, and then show them as success stories to bring in more and more users behind. But it's still it's a work in progress, right? Not everyone is jumping on the wagon to do this, but still it's a work in progress. And finally, once you establish such decentralization, it's very important that the discoverability of the data products is improved. So clearly followed by that, implementation of data marketplace is something also we are currently undertaken. So making sure that we are having an Amazon-like experience where you're able to discover all the data products you have in the organization, discover them, and not only discover them, but also get access to them through a single interface, which can trigger a workflow or through one-click approval processes. So to summarize our journey on this data products, so I would like to say that this is a continuous process, right? So we have to first understand systemically what is the challenge you're facing in the organization. Maybe for not everyone, a data mesh or data product is the answer, but trying to understand what are your systemic challenges you have in your company and trying to address them one by one in a continuous manner, improving it one piece at a time. And here the second part is building a data culture for sharing and understanding, making sure that sometimes the use cases and the AI applications are the main success in an organization. Sometimes people don't give much importance to the underlying data. So clearly, when we're sharing credits, it's important that the data products are also sharing the credits in the company, and we're able to foster this culture for sharing and also understanding about a data in the company. And focus on service, not on service. So clearly making sure that you're focusing data product as a service. So what you get out of it as a service and not focusing on the infrastructure aspects about a data platform. And reflecting on your past and improving, making sure that you're learning from your mistakes, from what didn't work, and making sure that you're not having a bad quality data, which is still there and not improving on that, it's not going to work, and constantly making sure you're getting feedbacks from your end users and improving your product continuously so that you get better than before. And clearly, having a data product mindset, which means converging of a platform thinking and a data thinking together. So I think this are some of our key learnings. I hope that you find this presentation interesting and useful. Thank you.
All right. Are there any questions?
Yeah.
Thanks a lot for sharing your journey and the transformation. So I think, like some of the aspects that you touched upon, especially like building that data culture, I think that's also something that we are going through right now with the data mesh transformation. I am just curious to know in terms of, especially like, since you're using so many new technologies, right? So what was it like to make that iterative transformation while also making sure that you can basically ensure that all of your people who work in data are able to like close up that knowledge debt? Because a lot of these technologies are like quite new. So I'm just curious like what your strategy is in that regard. Like for us, like we are looking at like a tech radar across the company, trying to standardize like some technologies that we want to use, evaluate what is being currently used and what we might be able to explore for new ones. So I'm just curious to know like how you're covering up that knowledge debt.
Yeah. So certainly certain level of standardization is needed. So doing a tech radar is a good step, but at some point we need to restrict the number of tools that we're offering in the stack. I mean, sometimes also a challenge from an IT management perspective is that having a zoo of tools, and that makes the scalability a big challenge. I was also talking during the lunchtime that during a proof of concept, a data scientist can work with some of the coolest tool, but as soon as you want to productionize it, it becomes much harder to take the same code and make it work in production. So it's much more important that we need to set certain standards, and also followed by that an enablement to make sure that we're able to follow that up with the right trainings and enablement. And also, if they're not able to do it, making sure there's a team that can support these use cases on this standard stack is needed. So certainly, we can't open up the whole thing. So even in our stack, you can see, right? So even though Azure has so many of tools, as the first version, we're only offering this much, just saying, right? So, and then based on the business problem, then we'll add more and more technical stack, not just to make sure that we are not overloading or the organization with too much technology. So this can solve most of the problem. If they're not able to solve any specific, then we add additional ones for that business problem. Not focusing on technology, but focusing on the business problem is much more important.
Got it. Perfect. Thank you so much. And what was the timeline for you to make the transformation?
So this project coincided with our company separation. When cars and trucks separated, two companies, this happened. So the old data lake went to the cars. So we took as an opportunity to rebuild a new platform for trucks. So we took this opportunity to reinvent the whole stack from data lake to data mesh. So you can say the last separation happened in November last year, December last year, and now we are September, so less than a year.
Perfect. Thank you very much.
As I said, this is still a work in progress. The platform is there, but now adaptation has to be now pushed. So we're going away from doing things to enabling the organization. So it's a much more bigger, longer journey.
Perfect.
All right. So maybe one more question? Anybody? Oh, okay. Yeah. That's.
What happens to the data integrity and master data management? Yeah, great question, right? So it needs to be considered. So when each of the data products are trying to build their own data product, there is tend to be duplications or even there is no single source of truth. People trying to build their own governance. So there's tend to be a lot of things can go into multiple directions, right? In such a decentralized environment. So certainly one of the key principles of data mesh is about federated computational governance. So which is trying to make sure that even though things are done decentralized, we are trying to make sure that we have the right tools to implement the governance. It's still a puzzle we have to solve. Hopefully, we will find some answer soon. But this is currently an open challenge for us. So how to make sure that such a decentralized environment can still maintain the integrity and single source of truth. Hope that answers the question. The second is what companies should have, data owners should have to own the data. Clearly, they should know about the data. Maybe not about the data engineering practice. Maybe we can hire data engineers for that. But clearly, what is the significance of the data should be known. They should know. They should be able to explain their data to a data scientist or data engineers. So I think today that's also a biggest challenge, right? So the data scientists are now given a data set and try to figure out with the catalog most of the times. But if it's a well-documented catalog, it's good. If not, it's a challenge. So clearly, the data owners should take ownership for the data, accountability for the quality. If there are issues in terms of GDPR or compliance, they should take ownership for that. But not necessarily they have to do things. It's not a technical role. It's more of an accountability role. So they can, of course, we can have it, how we now, in the past, data science role have moved from IT to business side. I think I also feel that in the future, more of the data engineering and data product ownership development role should also move to the business side to make this happen.